Right now I have a package here that I am trying to open up here. Here we are. It is a Savi's Workshop hilt. So a couple things about it. It's obviously broken, as you can see, and it does not have a battery pack. We can see it's clearly the plastic has snapped here. You can see the ribbon cable, we can see the power cable. They're still there, and they feel fairly connected. I'm curious if the hilt is still even any good. So I'm going to find a battery pack. Oh, well, there's one. And then I'm going to find yes, here we go. Here is a blade. What else do I need? Oh yeah, I should probably get a switch plate and an actual crystal as well. If I put the crystal in and press this button... Oh, it detects it! It detects it. That's a good sign. Now, it's not holding the crystal in place because, well, it's cracked, and so the pressure isn't there to keep it in place. Now, but do I hear anything when I insert the blade? That's the next question. It should be like that. Yes, I do. So I'm guessing, in theory, this would actually work. All right, good. You can't see it, but it's igniting. And it's white because the crystal has been coated white. It's flickering because this is one of my custom blades. The electronics in here are good, which is what I was really hoping for. Armed with that knowledge, that we've got a good chassis here. So my plan is, if I can, I'd like to just repair the chassis, and I just have a spare chassis. I have a few Savi's Workshop chassis, and they have different quirks, different electrical properties. That they consume different amounts of electricity when they're doing the same amount of work. Oops, there's a piece that is broken. They some of them, when I turn a blade on, when I try to ignite it, it needs a couple of ignitions before it finally turns on. There's a lot of weird stuff there, and I kind of want to see if I can figure out what's going on. Is there maybe a revision to the PCB that fixes that? But I want to get, several of these chassis to work with before I do that. The power and ribbon cable, it looks like somebody may have tried to glue that. I don't know. But I mean, this doesn't look good, does it? This is very brittle looking. This may not be repairable. Pull out the clip for the ribbon cable. There we go. Okay, let's just take a look at the bottom half here. I'll take a peek real quick just to make sure that, we didn't have some kind of battery leakage or anything. And no, everything looks fine. Yeah. And this bottom piece here, if you haven't seen the other videos I've done on taking these apart, this is where the meat and potatoes are. That PCB right there is like the main circuit board. And then there's another one down here that has the speaker and battery connectors on it. And there's a little board up here that has a little LED on it. It has the Hall effect sensor that detects when you... it detects the magnet in the switch to trigger the blade turning on. And it has a little ribbon cable that you saw. That runs up to another PCB up here that detects when this button is being pressed, and it also controls the LEDs that are up here. And then we have the power cable that's sending signals all the way up to the blade socket itself. I'll double check that the blade socket looks good. You can't see that, but I can. It looks fine. I want to get the top half off, because it's just this middle gray piece that's broken. Everything else is fine. So if I'm going to try and repair this, I'm going to try and glue this middle piece back together. There's no point in having the rest of this stuff attached to it. That should just come out. We have this piece here. At the moment, doesn't seem to want to come out. There we go. This just hides the ribbon cable and the power cable from view going up the side of the crystal chamber there. That ribbon cable is mangled. I'm surprised it still works, given how mangled it is. The power cable, maybe I want to see that this must have been glued. Somebody tried to glue this, I think, because there's all this residue here. But you can see that power wire there has been absolutely smushed. Yeah, and the copper's exposed right there, so I'd want to replace that too. 150 millimeter long wire that's soldered to a connector up here. So replacing them is a little bit difficult because you got to go up in here and dig out all the electronics up here. But to be honest, later on I may look at that cable again and decide that it's not worth digging around. I'll definitely replace the ribbon cable, though that's, the connector's right there. That's easy to replace. But just because of the hassle of getting up in here, when it's a stranded wire, stranded core, and I am not seeing any broken wires. It's just the insulation. So I could even temporarily remove it from the connector here, throw a piece of heat shrink over it just to sort of cover that one little spot up if I was afraid of, shorts forming. I don't know. It's something, it's an issue for future me. Present me doesn't care. Okay, analysis time. Well, it looks like that goes there. And I think it does. I think that has to be epoxy, doesn't it? But I mean, that definitely goes like that. And then it would go up here like that. See, I don't know if I could get away with epoxy though, because that would increase the thickness here, and I think the tolerances don't allow me to go there. So I think and maybe super glue would work too. But I don't know, I just have a better feeling with epoxy. I mean, it looks like that's cracked there too, so I'm thinking like this is going to be a kind of, lots of epoxy, sand it all down sort of thing. And this other piece go over here, right? Yeah. I don't know. What do I use? Do I use epoxy? Or do I use super glue? I don't know. Stay tuned. Alright, epoxy it is. The short story is anything that's going to be going under, that needs to withstand some significant force, epoxy is the way to go. Anyways, this is a piece of wax paper. I'm just trying to protect my work surface a little bit so I don't accidentally super glue or epoxy anything together. I'm going to use this stuff. This is plastic bonder, JB Weld plastic bonder. It's something that I had, so alright, I'll use that. Just try squirting some in here. Oh, and that's too much. That's way too much. Just start mixing this up. And I'm going to be using toothpicks to mix and apply, and you can clearly see that is, 10,000 times more epoxy than I need. With the understanding that I'm probably going to have to file or sand some of this epoxy down at a later time. Right now I'm more interested in just making sure I've got good epoxy coverage here. That feels like that's in there well. Trying to get the epoxy to spread across, both sides of the break here, just to kind of maybe help strengthen that bond a little bit. This allegedly hardens after 15 minutes. I'm not going to wait just 15 minutes. I'm going to hold it like this for 15 minutes, and hopefully I don't epoxy my fingers. And, oh, but then that's going to go off too, so I need to keep going. Uh-oh. I didn't think this through. I really didn't think this through. Yep, okay. Bring this back in. Oh, it's starting to get tacky. Too much epoxy. Now, if you're doing something like this, now I have a benefit in that I can just tell myself, if it doesn't work, you were never expecting it to work in the first place. So like there's no jeopardy for me. If it doesn't work, it doesn't work. It was a good try, nice experiment, and I get a little YouTube video out of it. But for you, hopefully, from the results of what I do here, if this happens to you, terrible light here, hopefully this can help you out. Okay, everything feels okay. This is something I do a lot when I'm gluing stuff like this. Is I play too much. I keep readjusting, and I usually wind up hurting myself more than helping myself. Okay. That's it. I'm done. I'll give you a quick focus. I'll give you a quick tour so you can see what it looks like now. And then I'm just going to put that off to dry. I'm actually going to let that dry overnight. And oh, I've done it. I grabbed the wrong end of that toothpick. You ever wipe glue and epoxy off on your jeans and then eventually it just goes away? Laundry machines are amazing. Okay. So we're going to let that chill for a little while. Again, overnight. This thing is just going to go somewhere safe and sit overnight. So a few seconds for you, at least 24 hours for me. So it's about 24 hours later, and I've already started going through this, trying to clean it up. And what I'm discovering is that while the epoxy appears to be holding the pieces together, it did not adhere to the external bits of the plastic here. It looks like it's only bonding where the cracks are. I mean, the stuff just sort of peels off. Let me see if I can show you an example here. I'm just going to grab a hobby knife here. And I can sort of see, just cut into it like it's putty, and it just comes right off. And you can just, look at this, you can just peel that right off. See? But the joints seem okay. But I feel like what I should have done, I probably should have taken like a file and scuffed up the surface. I bet that's where I've gone wrong here. And then that would have allowed the epoxy to better adhere to the surface, helping hopefully in theory to create a stronger bond so that this thing isn't going to break as soon as it gets under any amount of pressure. So I don't know how strong this bond is right now, and I don't know if I'm willing to test that. It seems okay. And the fit is kind of important here. Like I can't thicken the walls too much here, otherwise it won't fit back together. So I don't know, maybe I leave this alone? Or do I maybe cut little channels across these cracks here and add in another layer of epoxy? But I don't have any more epoxy because I used it all last time. So I don't know. Do I use different epoxy maybe? Maybe it's because I use that plastic epoxy, and this material is like a plastic with fiberglass. It's like, what is it? Fiberglass reinforced plastic. And maybe epoxy, maybe that style of epoxy I used isn't as good. I don't know. But I'm just gonna try cleaning this part up and see what it looks like. See if maybe it comes apart in my hands while I finish cleaning this up. But I don't know. It looks like it might have worked. I don't know. I don't know. So here we are. It's cleaned up enough. I've roughed the areas down, so if I ever do put epoxy on this again, maybe it'll hold better. But I don't have epoxy, and I don't think I have the width to add any significant amount of epoxy to this anyways. What I really would have to do is sand it down on the inside and the outside, and then put like a layer of fiberglass over it. Epoxy the fiberglass, then drill out all the holes and cut the holes at the notches. Yeah, I'm not going to do that. So it fits fine. That's the internal fit, right? That's fine. No problems there. And then the external fit is fine as well. So it seems to be holding. Maybe I got lucky and that plastic JB Weld stuff is going to do the trick. I don't know. We're going to find out together, I guess. Alright, so let's just put this thing back together, shall we? I will grab the bag that is full of all the extra bits and pieces that I need to put the hilt back together. We need tweezers here. I'm going to use these little curved ones here to get in here and release the ribbon cable. There's a little black piece of plastic here that sort of slides out. The goal is to try and get the tweezers on either side of it. It's not going to come across well on the camera. There we go. This cable looks okay for the most part, except for right here, where we have some exposed stranded wire there. And I want to put some heat shrink over it, so I want to lift the tongue here, this little tab here. I'll push the red wire in a little bit, try and get these tweezers underneath. There we go. And now that's going to allow me to slip a little piece of heat shrink over that. And I'm going to need some heat shrink. And I have this little bundle which has some small pieces of heat shrink. Because I'm already, one of the wires is already black, I want to use a different color. I don't have a thin red, but I have a thin green, so that's what I'm going to use. Trim that to a much shorter piece. And now I want to apply heat to get that to shrink. I'm going to consider that good. Now I just need to put this back. There we go, the wire's back in, can't pull it out. Good. I consider that a good repair. Alright, let's put the new ribbon cable in. One side is blue, and the blue part is covering the exposed wire. The other side has the wire exposed. The blue side needs to be facing towards the black clip, so it needs to face down. And I just slide it in like that. And I grab my tweezers and I'm going to push in on that black clip on either side. That should lock it in place and it doesn't want to come out. Good. So that's the new ribbon cable. It's going to go down this channel here, along with the power cable. So the power cable is going to sort of come over like that. The ribbon cable sort of right behind it. You might even give it a little bit of a twist and stick it in there, sort of like that. This little clear plastic cover comes up, and there is a indent on it right here. Matches up with the indent or the tab there. That's good. This piece has the windows on it. Look down the tube here, and if you look in the bottom there, you can see there's one piece of plastic that's sort of raised there. That needs to go through that channel. If you can see it, there we go. This channel right here. There's the channel. It's gonna go about like that. I'm using the windows here, should match here. The screw holes should match here. I want to grab this piece here, and we are going to have the non-broken piece, the side with the blue sticker going up that direction, and the channel, right, the grooved out area that has this cover goes into, right, is going to be where the wires are. So it's going to go in roughly, come on, like that. And see, this is where the ribbon cable and the power cable are going to sort of get held in place. And then that snaps in like that. And then I screw that in, and the top half is almost ready to go. Slide it counterclockwise. Hopefully you feel something click. I don't feel it, so I'm just going to gently go clockwise now. Goal is to not strip any threads as I'm putting these screws in, because the screws are metal, but they're screwing into plastic threads. Okay, now before we put this piece on, we need to think about the direction of the ribbon cable when it comes out. The ribbon cable is going to go into here. We can see the black plastic clip is on the bottom, so the blue needs to be on the bottom. So I want it to sort of come out like this, so that the blue is facing up or away from the center of the chassis, if that makes sense. So that way when it bends in, you see the blue is going to be facing down towards that black clip, which means that a little twist in the cable is needed. So it's just a matter of making sure you get that correctly when you line all this up. Now remember, the pointy piece is going up, right? So I need to also guide the cables behind the piece so they're hidden, like that. A little careful here to make sure that heat shrink doesn't get caught. All right, now we've got the plastic piece in the channel there. Now just very slowly, very gently push it up. The wires might get a little bit caught, a little bit snagged. Just sort of pull on them, pull any extra slack out. Keep pushing that plastic piece up until it is flush, like that, and you're good. All right, so that channel has now covered where those cables are, so you don't see them. And the blue is not facing the direction I need it to face, so I need to redo this. Same as before, I'm going to hold on to these cables, push that up, there we go. And now we've got the blue facing out as I wanted. Okay, we're getting there. Now we need to plug those wires in and then put the bottom piece on, and we are ready to test. Power cable in first. I have these flat tweezers I like to use for this. Try and just grab on to the wires right behind the connector, and then I can push down on the connector itself. There we go. Now those two wires there, the black and the red, carry power from the battery pack up to the blade, so it's very important you get these right. Come in to the clip with the ribbon cable, make sure we're straight. So now the excess of the ribbon cable is going to get tucked in below, like that. The power cable you can tuck in above. You can sort of give it a little twist and stick it in the top. Now because I've got a replacement ribbon cable, the blue piece sticks out farther than the stock ribbon cable, which has that black piece. So I have to sort of bend it a little bit down. You can sort of see from the side here, maybe. But that's it. That is in. Now, just like the top, we have that ridge there. And that's going to go through this channel here. So it's going to go in like here and line up the screw holes to help you make sure you've got it right. And well, there we go. And this is sort of the moment where we figure out if that epoxy is actually doing anything. Because if it's not, it's going to snap just like it snapped before. And keeping that in mind, I'm not screwing these in as tightly as perhaps I normally would, because of the way that epoxy was just peeling off of the this fiberglass reinforced plastic. And if it breaks, it is what it is. An effort was made. Didn't buy this to fix. Hoped I could fix it, but if I couldn't, it was parts, because I have another issue with other hilts that I want to fix. But there we go. It's back together. First fit and feel is good. Okay, I need a battery pack. There we go. Little magnet to test the switch. That's a very good sign. Tells me that the electronics are working, that it's detecting the magnet, the Hall effect sensor is good, so the electronics down here still good. Time to put in the wire, or the crystal, and this is where we learn whether or not the ribbon cable is working. Because the ribbon cable is carrying power for the LEDs up here, it's carrying the power for the switch to detect when a kyber crystal's been inserted. And I am seeing a white color, which this, even though it's a red crystal, I've coded it white. That way I can test all three colors, red, green, and blue, that are up here. Each color powered separately on that ribbon cable. So I see a white here. It tells me all those ribbon cables are good. All the connections are good. Next, I need a blade. Okay, time to insert a blade. It detected it. Very good, very good. Now this is one of my modified blades, so it might make some weird patterns here. That's normal. Here we go. And that is working great. Yep. So there we go. There is a fully repaired Savi's Workshop lightsaber hilt. And I hope you found this interesting, and I hope that maybe the next time you encounter a broken lightsaber hilt, or maybe something else, and maybe it's just a bit of broken plastic that you can glue back together, don't be afraid of giving it a go and trying to glue things back together, because at least right now anyways, it seems to have worked, which I'll be honest, surprises even me, but it worked. You see it, I see it, no problems, right? So go for it. You see a broken lightsaber hilt, give it a go. maybe you'll be able to fix it. You probably will be able to fix it. You'll be able to fix it.